a previous lecture we have learnt about the solidification of molten metal inside the mold, and we have also learnt how to control the grain structure and how to overcome the problems that are likely to arise during solidification inside the mold. Now, once we pour the molten metal inside the mold, after some time it solidifies and we have to take the casting outside, and we need to process it further so that we can get the casting which can be handed over to the customer. Now, in this process we have to further process the casting. This is known as the shakeout, fettling and finishing. So, the title of this lecture will be shakeout, fettling and finishing. There are three parts. First we will see the shakeout. What is shakeout? When the molten metal has solidified, the solidified casting is removed from the sand in the molding boxes. This operation is known as shakeout, and here we can see the solidified casting is being taken out from the mold, means we break the mold and we take the solidified casting outside. And here also we can see this is the solidified casting, and surrounding the casting we can see that is the broken mold. So, breaking that mold and taking the solidified casting is known as shakeout. Now, how to carry out this shakeout? Methods of shakeout. One is dumping of the mold assembly upside down on a bench or ground. Just take the mold box, inside there is solidified casting, and make it upside down on a bench or a ground. The mold will be dropping down from the molding boxes, and the mold also at the same time it will be breaking into pieces. The casting can be taken outside. Second method is the break the sand mold by striking against the sand mold, right, with a metal rod or a hammer. No need to put the molding box on a bench, or no need to make it upside down. Take some rod or a hammer and strike it. The mold will be broken and the casting can be taken out, and this also can be achieved by using machines. So, these are the different machines are available. One machine is the punch out machine, another one is the shakeout tables and decks, next one vibrating shakeout conveyors, next one rotary separators, next one robots and manipulators. We will see this quickly. Punch out machines, first we will see punch out machines. In punch out machines, the entire mold and the casting are ejected from the molding box using a punch, right. So, this molding box along with the mold and the solidified casting will be kept on this machine, and there will be a punch will be there. The mold box will be held rigidly and this punch will come and push the mold. What happens? The mold will be coming out of the molding box, at the same time it will be broken and the casting can be taken out. So, that is the punch out machine. Next one is the shakeout tables and decks. Now, shakeout tables separate the mold and the casting by making vibrations to the table, and here we can see here is a table, right. So, on this table we place the molding box along with the mold and the casting. Now, vibrations will be given to this table. Then what happens? As the table is vibrating, the mold will be breaking and it will be coming out of the box, and the casting can be taken out. So, that is the shakeout table and decks. And the next one is the vibrating shakeout conveyors. Now, these are the conveyors, right. So, these conveyors are available in about 100 meters long and width up to 4 meters. On these conveyors, the molding box will be kept along with the solidified casting. Now, this will be vibrating as it is bringing the mold, right. So, it will be vibrating, and because of that the mold will be broken and the casting can be taken out. Next one is the rotary separators. It offers improved sand breakup and automatic break off of gates and often risers. Now, here we can see rotary what say separators are there, right. It is a kind of cylindrical structure and it will be rotating, and this molding box generally small and medium size molding boxes along with the mold and solidified casting can be kept inside this rotary separator. Now as this is rotating, what happens, the mold inside the box will be breaking. In this process the casting comes out. Not only that, not only the casting comes out, what happens is the gates and often even the risers will be separated from the casting. Now one must remember that when we are pouring molten metal into the mold, you should not think that the metal will be solidifying only inside the cavity. Metal will be solidifying inside the gating system, means inside the sprue, inside the runner, inside the gates, inside the riser, everywhere metal will be solidifying, but we do not want everything, we want only the required component. The metal that has solidified inside the sprue, the metal that has solidified inside the runner, inside the ingates and inside the runner is not part of the casting, that has to be removed. Now sometimes because of this rotary what say mechanism, these extra what say elements like the sprue, gates, runner will be broken because of this rotary mechanism. So that is an additional advantage of this rotary separator. Next one, robots and manipulators can also be used for the shakeout purpose. Now sometimes the most what say one of the problems in the foundry is the dust problem. Sometimes if the dust is too much, the operator cannot go there. At such times robots and manipulators can be used, right. So the manipulator can be what is programmed such that it goes to the mold and it takes the mold and it breaks the mold and take the casting outside, and the operator can be what say placed in a such a place that there is no dust contact between him, right. In that way robot will help so that the operator can be free from the dust. So robots and manipulators can also be used for the shakeout purpose. So far we have completed the shakeout. Next one is the fettling. What is fettling? Fettling means it includes the following operations: removal of cores from the casting. Whenever we want to make hollow castings, we place cores. Generally these cores are made up of core sands, right. So these cores are again to be removed. When we are doing the shakeout, these cores may not be removed. So in the fettling operation we will be removing the cores. Next one, removal of gates, risers, runners from the casting. Remember that metal will be solidifying inside the sprue, inside the runner, inside the ingates and also inside the riser. These are not part of the castings. Now these are to be removed. Now in the fettling operation we remove these gates, risers and runners under the sprue from the casting. So that also comes under fettling. Next one, removal of fins and other unwanted projections from the castings. Generally sometimes fins will be what say taking place, right. So always we use generally two molding boxes, the cope and the drag. Upper box is the cope and the lower box is the drag. Between sometimes if the sand is not what say edged properly, not leveled properly, there will be what say narrow gap between these two boxes, then metal will go and solidifies there. Then what happens? A fin will be created. Now these fins are to be removed, that also comes under fettling. Next one, removal of adhering sand and oxide scales from the casting. Now during the shakeout, right, of course the mold will be broken and we take the casting outside, but the casting will not be totally free from sand. Some sand will be adhering to the casting. So this sand is to be removed. Sometimes even oxides will be adhering to the casting. These oxides are to be removed. So this process is also comes under fettling. So fettling means all these processes, all these activities come under fettling. Now let us see how to carry out all these fettling operations one by one. First let us see removal of cores from the casting. How to remove the cores from the casting? Removal of cores from the casting is achieved through the following methods. One is hammering or vibrations imparted to the cores. Second one, poking with a metal rod. Third one, pneumatic wrapping or hydroblasting. Right. So, hammering or vibrations can be imparted to the cores and cores will be removed. They will be crushed and they can be removed. Next one, we can use a metallic rod and we can poke it. Then it will be crushed and it can be taken out. Next, pneumatic wrapping or hydroblasting means pneumatic wrapping means high pressurized air will be exposed to the place where there is a core, and because of that high pressurized air the core will be broken and it will be falling down, or high pressurized water, that is it will be used, that is the hydroblasting. So, any of these can be used. So, that is all about the removal of cores from the casting. Next part of the fettling is removal of gates, risers, runners from the casting. Metal solidifies inside the sprue, metal solidifies inside the runner, inside the ingates and also inside the riser. We need to remove all these elements, gating elements. Now, that also is part of fettling. How to do that? Right? Several methods are available for removing gates, risers and runners from the casting. The choice depends upon type of metal or alloy, size of the casting, next one size of the runners, gates and risers. Commonly used methods of removing gates, risers and runners are, one is the chipping hammers, next one flogging means severe striking, next one sawing, it could be hacksaw or the bandsaw, next one abrasive wheel slitting, next one machining, next one flame cutting, next one plasma cutting. Any of these methods can be used to remove the elements of the gating system, means the sprue, runner, ingates and the riser. Now, we can see this is the chipping hammer, right. So, we can see here. So, they are particularly suited in case of grey iron castings and brittle materials. The gates and risers can easily be broken by hitting with the hammer, and when we strike with this hammer, so these elements of the gating system can be broken very easily. Next one, flogging. Flogging means striking very severely, right. So, using this method also one can remove the elements of the gating system. Next one, sawing, right. So, these saws may be hand saw or power saw type. They are used for cutting the ferrous like steel, malleable iron and for non-ferrous materials except aluminum. Mostly the hand saws are used for small and medium castings, but power saws are used for the heavy castings. Next one, abrasive wheel slitting. These machines can work with all metals, but are specially designed for hard metals which cannot saw or sheared, and it is more expensive than other methods. Next one is the flame cutting. This type of method is specially used for ferrous materials and large sized castings where the risers and gates are very heavy. In this method, the gas cutting flames and arc cutting methods may be employed, and it is not for small castings. Sometimes there will be heavy castings will be there, right. The riser may be very big risers. Now, with hand saw it may not be possible to remove that riser. At such times we use the gas cutting flames, right. So, we can easily remove that, and also using the arc cutting methods we can easily remove such heavy elements of the gating system. Next step of the fettling is the removal of fins and other unwanted projections from the castings. How to do that? Fins and other unwanted projections can be removed by the following methods. One is the chipping, second one is the sawing, third one flame cutting, fourth one flame scarfing, next one grinding, next one abrasive belt machines, next one rotary tools, and finally trimming and sizing. Any of these methods can be used for removing the unwanted fins from the castings. And the last step of fettling is the removal of adhering sand and oxide scales from the casting. How to do this? One is the hand methods, second one is the mechanical methods. Under the mechanical methods, we have generally 4 methods are there. One is the tumbling, second one is the air blasting and shot blasting, third one is the hydroblasting, fourth one is the chemical cleaning. Tumbling, a horizontal barrel is filled with the castings which is then rotated. There will be a horizontal barrel will be there, inside we place the castings, and usual media include water or other lubricants. It will be filled with water or lubricants. As the barrel is rotating, what happens? Castings will go up and will go down, and in this process the oxides will be removed. But this method can be used only for small and moderate size castings, and here we can see these are the rotating barrels used in the tumbling. So, here we fill the media, maybe water or the lubricating oils, and we put the castings inside and the barrel will be rotating. As it is rotating, the casting goes up and goes down, goes up and goes down. In this process, the oxides will be removed from the casting. Next one, air blasting and shot blasting. Air blasting utilizes an air compressor's energy to deliver air and media mix at speeds to impact the parts being exposed. Now, here we use air and also certain abrasive materials. Now, here we can see in this the compressed air will be coming like this, and one stream of this compressed air will be going through the nozzle. Yes, this is the nozzle, and another part of the compressed air is coming, and here there is a blast media collection is there. There it will be opening when this compressed air comes and it lifts the gate. The abrasive particles will be falling down. Now, these abrasive particles here we can see they will be mixing with the compressed air. Together the mixture of the compressed air and the abrasive particles will be flowing through this nozzle, and this nozzle will be exposed to that place of the casting where there are oxide. Now, when the high pressurized air along with the abrasive particles hit the place, the oxides will be removed because of the kinetic energy of the abrasive particles. So, this is the air blasting and shot blasting. Next one is the hydroblasting. It refers to the use of high pressure pumps to enter the high pressure water, high pressure jet to the casting surface. This method is mainly applied to the surface of the larger pieces of casting to clear sand and to clear the cores, right. So, when the casting is very big, right, so pressurized water will be exposed to that place where there is sand is adhering or oxides are there. So, they will be removed. So, we have completed the shakeout and the fettling. The third part of this process is the finishing. Finishing of the casting, it is the last stage in cleaning of the casting. It includes grinding for better surface finish. Next one, rotary filing, that is also for better surface finish. Next one, for machining, means if there is any dimensional deviation we do the machining. Next one, chemical treatment to achieve the required surface finish and also to achieve the required geometrical accuracy. Next one, polishing and buffing, surface treatment, and finally painting. So, all these come under the finishing operations. Now, these are well known: grinding, rotary filing, machining and chemical treatment. So, I will be explaining the polishing and buffing and the surface treatment. So, first let us see this polishing and buffing. Polishing and buffing are finishing process for smoothing a workpiece's surface using an abrasive and a work wheel or a leather strap, right. So, here we can see, so this is a polishing wheel, right. So, technically polishing refers to process that use abrasive glued to the work wheel, right. here we can see this is the leather wheel and abrasives are glued to this leather wheel. Now this will be used to polish the casting, while buffing uses a loose abrasives applied to the work wheel. So extremely small material is removed from the workpiece. The main aim of polishing and buffing is not to remove the material, not to achieve geometrical accuracy, but to achieve extreme surface finish. Now the purpose of surface treatment. Next one, let us see the surface treatment of castings. Purpose of surface treatment: one is to improve the appearance, second one is to improve corrosion resistance. Next one objective of surface treatment is to improve wear resistance. Next objective is to improve mechanical properties on the surface. So when we do the surface treatment, any or all of these could be the objectives. Now methods of surface treatment: one is electroplating, second one is the tinning and galvanizing, third one is the anodizing, fourth one pickling, fifth one carburizing, sixth one nitriding and nitrocarburizing, seventh one flame and induction hardening, eighth one hard facing. Now let us see all these one by one. Electroplating. Electroplating is the process of plating one metal onto another metal, right, mostly for decorative purpose or to prevent corrosion. There are also specific types of electroplating such as copper plating, silver plating, right, and chromium plating. Now what is the purpose of electroplating? One is to improve the appearance, second one is for protection, means protection from corrosion, protection from wear. Next one, to achieve special surface properties, maybe surface may be soft, we want hard surface, inside we do not want hard. So in such a case we go for the electroplating. Next one, engineering, to improve engineering or mechanical properties of the casting. In such a case we can go for electroplating, and here we can see this is the principle of electroplating, right. So it depends what say on the principle of the electrochemical what say decomposition. Now here is an anode and here is the cathode and an EMF is applied, then what happens, and electrolyte is present in this tank, then what will happen, material will be removed from the anode and it will be deposited on the cathode. The same principle will be applied in this electroplating, means the casting will be made as the cathode and the material with which we want to give a coating will be made as the anode, and these two will be kept inside the electrolyte and EMF will be applied. Then what will happen, material will be removed from the what's a material which we are using as the coating and it will be deposited on the casting. And same here also we can see this is the silver electroplating. So silver here it is used as the anode, and maybe for example there is a spoon, right, then what will happen, when we pass the electricity, material will be removed from the silver and it will be deposited on the spoon which is the cathode. Next one is the tinning and galvanizing. What is tinning and galvanizing? Tinning is the process of applying a protective tin coating to steel or iron components to prevent rusting. So to prevent rusting or to what say achieve corrosion resistance, we do this tinning. It is done in two ways. One is the hot dipping, second one is the electroplating. In the case of the hot dipping, we melt the tin in a container and the casting will be taken and it will be dipped inside the molten tin and it will be taken out. Then what will happen, a thin layer of tin will be applied on the casting surface. So that is the tinning. Next one is the using electroplating, also we can do the tinning, means electrolyte will be made as the anode and the casting will be made as the cathode. Now an EMF will be applied and they will be kept inside an electrolyte then what will happen, material will be removed from the what say tin and it will be deposited on the casting. So that is how we can do the tinning using electroplating operation also. Next one is the galvanizing process. Galvanization is the process of applying a again protective zinc coating. In the previously it was a tin coating, now it is the zinc coating to steel or iron components to prevent rusting. Again our objective is to improve the corrosion resistance. This galvanizing process consists of 4 fundamental steps. One is the surface preparation, next one pre-fluxing, next one galvanizing, next one finishing. So these 4 steps one has to follow when he is doing galvanizing. Now here we can see different steps involved in galvanizing process can be seen. First one is the, so this is the component, first step is the caustic cleaning, means with an alkali it should be cleaned thoroughly. Next one, after cleaning it should be removed. Next step is the pickling. Pickling means if any unwanted material is there, unwanted scales are there, so those will be removed in a chemical or a mild acid. Next one, after that again rinsing, because that acid has to be removed. If that acid layer is present on the casting, what will happen, it keeps on reacting with the casting, so that must be removed. So we are doing rinsing. Next one, flux solution, after that it will be dried out. Next one, here we can see, here is a zinc bath, means molten zinc is inside a container. Now the casting will be taken and it will be dipped inside the zinc bath, then it will be taken out and it will be dried out. Next it will be cooled down and then it will be inspected whether the zinc is applied all around or not, like that it will be inspected. So these are the sequence followed in the galvanizing process. So galvanizing means applying a thin coating of zinc around the casting. Our next process for the surface treatment is the anodizing. Anodizing is again an electrochemical process that converts the metal surface into a decorative, durable, corrosion resistant and anodic oxide finish, right. Aluminum is ideally suited for anodizing, although other non-ferrous metals such as magnesium and titaniums can also be used. Our next step, next method in the surface treatment process is pickling. Pickling, what is pickling? Pickling is the process of removal of a thin layer of metal from the surface of the casting by using an acid like nitric acid, hydrofluoric acid or a mixture of such acids. The ultimate objective of pickling is to remove scales and oxides from the surface of the casting, right. Sometimes oxides will be there, scales will be there, it is very difficult to remove using the hydroblasting or pneumatic blasting. At such times we use the pickling. So what is there in pickling? There will be a tank will be there, in that tank then what say acid will be there like nitric acid or hydrofluoric acid. The casting will be kept inside this what say container for a predetermined time. Then what will happen? The acid will be reacting with a thin layer of the casting and that layer will be removed. In this process even the scales will be removed from the casting. Now the casting will be free from the castings, what say oxides, it will be free from the rough surface. Finally we get a casting with a better surface finish. Now there are 3 pickling methods are there. One is tank immersion pickling, next one is the spray pickling, third one is the circulation pickling. In the tank immersion pickling, what happens, there will be a tank and inside that tank there will be acid. The casting will be kept inside that tank for a predetermined time and the acid will be reacting all around the casting. If there are scales, scales will be removed. If there is a rough surface, that rough surface will be reacting and finally a free surface, fine surface will be created on the casting. That is the tank immersion pickling. Next one, spray pickling. So this is used for the it is an on-site pickling process but requires appropriate acid disposal techniques and safety measures. What is this? If the casting is a small casting or a medium size casting, we can put it inside the tank. If that casting is a heavy casting, how can we put it inside the tank? It is not possible. At such times we go for the spray pickling, means yes, we take the big casting and wherever there are scales, there we what say sprinkle acid, right. So that acid will be reacting with the scales and those scales will be removed, but we need to wash it after the what say spray pickling is over, and also appropriate measures have to be taken so that these acids will be disposed very safely. Next one is the circulation pickling. What is this? In this, the circulation pickling involves circulating pickling mixtures through the component like a pipe. Suppose if the casting is a big cylindrical pipe and it can't be kept inside a tank, and also certainly the spray pickling will not do, then what to do? Certainly we have to go for the circulation pickling. What happens inside the circulation pickling? The acid will be flowing through this what say cylindrical casting inside. So the inner surface will be finished, the inner surface it will be improved, the scales that are present inside the inner surface will be removed. So that is the purpose and objective of circulation pickling. Next one is the carburizing. Carburizing is a process used to case harden the component by adding carbon content to the surface between 0.7 to 1.2% weight percentage. The objective is to case harden, means we want to harden the surface, not the entire casting. The carbon penetrates into the surface of the casting by diffusion and hardens the surface. It is possible to apply carburizing medium to only a section of the part. Sometimes the entire surface of the casting need not be what say hardened by carburizing method, only at a what say particular place we want to harden the surface, that is also possible. Now carburizing methods, there are three methods. One is the pack carburizing, second one is the gas carburizing, third one is the liquid carburizing. In the pack carburizing, parts are packed in a carbon powder or cast iron shavings and heated in a furnace for 12 to 72 hours at about 900 degrees centigrade. Then what happens? The component is packed inside the carbon powder or cast iron shavings. Carbon is released due to reduction reaction, right? Yes. Then that carbon diffuses into the surface, then it hardens the surface. So that is the pack carburizing. Next one, gas carburizing. Generally the casting is repeatedly heated with the carburizing flame of oxyacetylene gas torch and quenched in a carbon rich fluid such as oil. Now we use the gas welding, right? So we use the oxyacetylene gas, acetylene and oxygen. Then again in this what say flame, there will be three types of flames will be there. One is the carburizing flame, neutral flame and the oxidizing flame. We use the carburizing flame, means the proportion of acetylene will be more, means the what say flame contains rich carbon. Now with this flame, with this carburizing flame, we heat the surface of the casting. Then what happens? The carbon that is present in this carburizing flame will be diffusing into the surface of the casting. The surface of the casting will be hardened and then it will be quenched in a oil. So that is the gas carburization. Next one, liquid carburizing. What is this? The components are immersed in a molten carbon rich bath at an elevated temperature, right. So there will be a bath which contains a molten carbon and it will be at an elevated temperature and the component will be immersed in that bath. Then what will happen? The carbon from the what say this rich carbon bath will be diffusing into the surface of the casting and the surface of the casting will be hardened. So carburizing is for hardening the surface of the casting. maybe the entire surface or a part of the surface. The next process of the surface treatment is nitriding and nitrocarburizing. Both nitriding and nitrocarburizing are low temperature treatments that produce thin and hard layers on the surface of a steel casting to improve its wear resistance. The purpose of carburizing is to harden the surface, whereas the purpose of nitriding is to improve the wear resistance of the surface. In both the treatments, right, diffuse nitrogen into the surface of the components to form a thin layer. Nitrogen will be diffused. In the previous case it was carbon, now it is nitrogen, right. Ordinary nitrogen is inert at the treatment temperatures, whereas ammonia acts as a source of nascent hydrogen as it cracks on the component, right. So, we need the nascent nitrogen, for that purpose we use ammonia. Now, let us see the nitriding. In nitriding, the nascent nitrogen diffuses into the component and forms a thin layer. The treatment temperature is low and no need for quenching, hence there will be less distortion. In the case of the carburizing, what happens after the carburization is over, after the diffusion of the carbon is over, we used to quench. So, in the process of quenching there will be distortion of the casting, means there will be irregular deviations of the geometry. Here no such distortion takes place. The layer produced by nitriding is harder than the layer produced by carburizing. As far as the hardness is concerned, nitriding produces better hardness compared to the carburizing. Next one, however, its typical heat treatment time is 60 hours as against 12 hours for carburizing. Carburizing, right, it requires only 12 hours, whereas nitriding requires 60 hours. Now, there are three types of nitriding process. One is the gas nitriding, second one is the salt bath nitriding, third one is the plasma nitriding. In the gas nitriding, right, when ammonia comes in contact with the heated workpiece, it dissociates into nitrogen and hydrogen. This nitrogen diffuses into the surface of the casting and forms a nitride layer. So, this is the gas nitriding. Now, what about the salt bath nitriding? Nitrogen bearing salts which are maintained between 500 to 630 degrees centigrade produce a highly uniform release of nitrogen at the interface of the workpiece, right. So, when the hydrogen bearing salts are heated at about 500 to 600 degrees centigrade, nascent nitrogen is released. So, when we place the workpiece inside this bath, then what will happen? This nitrogen will be diffusing into the surface of the casting. Then what will happen? It will be hardening the surface of the casting. Next one is the plasma nitriding. In this technique, intense electric fields are used to generate ions or the plasma of the nitrogen gas around the surface to be nitrided. Then what will happen? The nitrogen plasma penetrates into the component and forms a thin layer which is very hard. So, that is the plasma nitriding. Next one is the nitrocarburizing. It is little different from the nitriding process, right. It is a thermochemical diffusion process where nitrogen and also carbon and a very small degree of oxygen will be diffusing into the surface of the steel part, forming a compound layer at the surface and a diffusion layer. Now, what is one should know the difference between nitriding and nitrocarburizing. Nitriding means we are only sending the nascent nitrogen inside the surface of the casting, whereas in the case of the nitrocarburizing we are sending nitrogen, carbon and an extremely small amount of oxygen also. All these three will be going together, they will be diffusing into the surface of the casting and they harden the surface. In addition to the wear resistance, so you see the basic purpose of nitriding is to improve the wear resistance, right. In addition to wear resistance, nitrocarburizing provides corrosion resistance and aesthetically pleasing black finish on the component. Apart from improving the wear resistance, it also improves the corrosion resistance, this nitrocarburizing, and also it gives an aesthetical pleasing look to the casting, and also it also improves the fatigue resistance. So that is all about the nitrocarburizing. Next one is the flame and induction hardening. So this is the next method in the surface treatment process, flame and induction hardening. Flame hardening is a surface hardening method used for steel components. The steel component to be hardened is heated using oxyacetylene gas above the transformation temperature. Then it will be quenched in a spray of water. The thickness of the surface layer hardened by this method will range from 1 mm to 10 mm. So this is the flame hardening, means we will be heating the cast component using the oxyacetylene flame, and suddenly it will be quenched with a spray of water. So this is the flame hardening. So here we can see, yes, the component is being heated by the what's a flame, then it will be quenched. Next one is the induction hardening. Induction hardening is also used to harden the surface of the steel components, and it is similar to flame hardening. Now the component to be hardened is kept inside a water cooled copper coil, and high electricity is passed through the copper coil. Means if we want to induction harden a component, that component will be kept inside a copper cooled copper water cooled copper coil, right. The component will be inside this coil, and high electricity will be passing through that coil, and inside that coil there is the component. Now what happens, and because of the passing of the because of the electromagnetic induction, eddy currents will be developed inside the component. Now as the eddy currents are passing through the component, what happens, the component offers resistance to the eddy current. Then what happens, if it offers the resistance, right, that too these eddy currents will be passing around the surface of the casting. Then what will happen, but the surface of the casting is offering resistance to the flow of eddy currents, then what will happen, heat will be generated. Now then the component will be heated up, then at such times it will be suddenly quenched with water. Then what will happen, the surface of the casting will be hardened. So this is the induction hardening, and here we can see, yes, this is the magnetic field, right. So this is the copper coil, right, and this is the component, and we are passing the current through this coil. Then what happens, on the surface of the casting there is induced current in the part. This induced current or the eddy current is due to electromagnetic induction. As the eddy current is passing through the component, the surface will be heated up, then it will be quenched, and maybe the setup may look like this, right. So this is the power supply, and this is the coil, and right, this is the component, and here we can see this is the quench water. Next quench water, next this is the water cooled, this is the copper tubing, and then what happens, when we pass the electricity, eddy currents will be developed and the surface will be heated up, and suddenly it will be quenched. The machine looks like this, induction hardening machine. Yes, this is the coil, and this is the coil, and this is the casting, and you see, as we pass the main current, primary current through the coil, because of the electromagnetic induction, the surface of the casting will be heated up like this, then it will be taken out and it will be quenched inside the water. Next we will see the hard facing under the methods of surface treatment. Now the question is, what is this hard facing? Hard facing is a deposition of hard and wear resistant material on a component surface by welding, right. So we take hard and wear resistant material, and that will be taken in the form of an electrode, then it will be deposited on the what say components surface by welding. There are several techniques of hard facing. One is the gas welding, next one is the arc welding, TIG welding and laser welding. In all these cases, the hard and wear resistant material will be melted and a thin layer of this material will be deposited on the component's surface. The welded surface is much more resistant to wear and abrasion. Now, what is happening? The material, the component may not be so hard in the beginning and it may not have so much of wear resistance in the beginning. Now, we are taking a material which has got which is very hard and which has got highest wear resistance. Now, this material we are taking and we are depositing a thin layer around that component. Then what will happen? The welded surface is much more resistant to wear and abrasion. So, we are hardening the component on the surface and also we are enhancing the wear resistance of the component at the surface. So, that is the principle of hard facing. Now, this it is how this hard facing is carried out. So, this is the component. Now, this is the gas torch and as the gas torch is progressing around the workpiece, the component will be the material, the hard face material will be taken in the form of a filler rod and that will be melted and that will be deposited around the surface. So, not only by using gas torch, there are other ways. Just now we have seen it can be done using arc welding, it can also be done by TIG welding or it can also be done using laser welding. In any of these process or using all of these process, this hard facing can be carried out. Friends, in this lecture we have learnt about the surface treatment of the castings. Under that we have seen different methods of the surface treatment. One method is the electroplating, another method is tinning and galvanizing, and another method is anodizing, another method pickling, another method is carburizing, another method nitriding and nitrocarburizing, and another method flame and induction hardening, and the last method is the hard facing. So, with this we are completing the surface treatment of the castings and we will meet in the next lecture. Until then, bye, thank you.